In this video, we are going to go over a couple of examples of how to start with the graph of a line and then write the slope-intercept form of the equation for that line. Super cool stuff. Let's do it. So what we're instructed to do is write the slope-intercept form equation for the line in the graph. So I've given you a graph, and you're asked to write the slope-intercept form of the equation of the line. So what I always tell students to do is start with your end game in mind. Start with the form that you want this equation to be in at the end of all this. Well, you're told we want the slope-intercept form. So that is y equals mx plus b. And we've seen in previous videos that slope-intercept form needs a slope to tell us how to move, as well as a b value of telling us a location of where to begin. I'm going to start out by first locating where we cross the y-axis. In other words, find the b value, the y-intercept. Well, that's going to happen along this y-axis. So the line crosses the y-axis right here. So let's locate that point. That's the point that is up 1, 2 from 0, 0. So it's the point 0, 2. So the y-intercept itself, if we're being very particular, the y-intercept is the point 0, 2. As a b value goes, we take the y value. And that's because when we plug in 0, that'll cancel out and we want to be left with a y value of 2. Plug in 0, get out 2. So the b value is 2. That's it. Now we need to find our value for the slope. Now we've done this in a previous video, so we're kind of just putting together the idea of here's a graph of a line, let's find the slope. So that's hopefully some old school math that you now know how to do. So you pick two nice points, right, that are on the line. A nice point would be defined as a point that is very clearly at an intersection of some of these gridded lines. So I'm going to go from this point to this one here. You could go from this guy to this guy or this one to this one. Go with the two closest points you can to reduce error. So we go down 1, here I'll count it out, 1, 2, 3. So that's down 3, so that's negative 3. And then from this point we go over 1, 2, 3, 4. So that's to the right 4. So our rise is going down 3 and our run is going right 4. Therefore our slope of down 3 over 4 is not so bad. M, or slope, is down 3, right 4, or rise negative 3 over a run of 4. Okay, now from here, all we have to do is literally take that information and insert it or plug it into the template. So y is equal to, the template being this guy right here, y equals a slope of negative 3/4 x plus a value of 2. That's your b value. And that's it. That is the equation of your line, and it certainly makes a ton of sense. If you take this, you start at 2, and then you go down 3 over 4. Down 1, 2, 3 over 1, 2, 3, 4, and we're still on the line. Beautiful. I'm going to go over one more example of this in the other side of this video in case you're looking at it saying, whoa, I need one more example to understand what's going on here. No sweat. See you on the other side of the video. And here we are on the other side of the video where we are going to write the slope-intercept form equation for the line in that graph just over my shoulder. So how do we do that again? We're going to follow the same ideas that we talked about before. I always start out by writing out the template, right? The main idea or the form that I'm going to want my final answer to be in. In this case, I recognize slope-intercept form, which is y equals the slope m times x plus the y-intercept b. So all we need to do now is find the slope and find the y-intercept. I like to find the y-intercept first because that's normally what I graph first. So I'm going to look to the y-axis to see where the line intercepts or crosses the y-axis. And it happens right here. That happens at the point 0, 0. So that's a y value of 0, which means that my b value is equal to 0. Now, if your teacher asks you to actually label the y-intercept, which I'll abbreviate with int, you would write that as the point 0, 0. And that's just looking at the graph and saying, that is the point where we cross the y-axis. From here, it's up to us to figure out how we move from that point to the next nice point on the graph. That movement will give us the slope. So let's determine the slope of the line now using our rise over run techniques. So I have this point and maybe the next one will be good here. We could go down to this point. It's up to you how we do it. So I noticed that to get to this point, I'm going to be moving up 4. So that's up 1, 2, 3, 4, and then over 1. Or you could draw in a triangle and see that we moved over 1, and then up 4. Either way, the upwards motion of 4 is a rise of positive 4 and a run of 1. You could also look at this point and say I went down 4, left 1. That would be negative 4 over negative 1, which is positive 4 over 1. So our slope is technically just 4, but I advise students to write that as 4 over 1 just to see how we're moving. In the final product, which we're about to do, and not multiplication product, but the final actual result, we are going to put in just this single number in simplified form. So here we go. It's y equals mx plus b. Y equals, the slope m is 4 times x plus 0. Now, many teachers will not like that as an answer because that's not in simplest form, because technically, if I had 4x plus 0, that's the same as just saying 4x. So I would want you to write your answer as y equals 4x, which makes a lot of sense. For every one x value, we go up 4, over 1 up 4 to the next point, over 1 up 4, and we intercept at y equals 0. It's a beautiful thing, peeps. Graphing slope-intercept form, a major idea in math that you'll actually use for years to come, hopefully made very simple.